Alright, so for my material today, I chose to go over carbon fiber. First, we're going to look at the history of the material. Next, we're going to look at how carbon fiber is manufactured. Third, we're going to look at the mechanical properties and the atomic structure of carbon fiber. Next, we're going to look at the fatigue and failure on carbon fiber that can occur during its applications. Next, we're going to look at the economic and environmental impacts of carbon fiber. And lastly, we're going to look at the applications in everyday life. Alright, so some history on carbon fiber. It's important to understand the history so you can understand the purpose of the material and where it came from and how it started. Carbon fiber was first discovered by Sir Joseph Wilson in 1860. This form of carbon fiber was used in an early form of the incandescent bulb. The reason that we don't see this today is we found more efficient and effective way to make incandescent bulbs, and now we have actually LED bulbs. Because of this, for roughly 100 years, we don't see carbon fiber pop up at all. In the early 1960s, Dr. Akio Shindo used a synthetic polymer to create a carbon fiber with roughly 50% carbon, making the strand of carbon very cost-effective and efficient for mass production. Over the next 10 years, the carbon fiber would be improved to become a very cost-effective and efficient material that would eventually replace metal alloys for its weight and strength ability. The fibers in today's industries roughly use 95% carbon and have a high tensile strength as well as significantly higher modulus of elasticity than the ones we see in 1960. Material specialists have recently discovered the variety of applications and potential for carbon fiber that can be transformed for any application. Next, we're going to look at how it's made. It's important to understand how carbon fiber is made so we can understand the applications that it can occur in, as well as the materials that it can replace. To manufacture carbon fibers, there are several operations that have to be completed. It's going to start out with a plastic fiber composed of thousands of filaments thinner than the human hair. It is then chemically altered to form a perfect chain of carbon atoms to make a composite material of carbon. They then are going to travel through an oxidation oven that has roughly 400 degrees Fahrenheit, which allows them to pick up oxygen molecules. This allows the fiber to have a high melting temperature of roughly 365 degrees Celsius. As the fibers are oxidizing, they then change color to turn black, which will prime them for carbonization. Next, furnaces will heat the fiber in an oxygen-free gas chamber. This will help expel the non-carbon atoms and will transfer the carbon atoms into bonded crystals. This process gives the material its high strength ability. Next, the fibers will go through a bath of electrified water, which allows them to absorb the resin. After going through this process, the fiber will be coated with a layer of resin, which will strengthen the fibers. After the first layer of resin is applied, a machine will spool each fiber into its spools. As these fibers are spooled, the material will either be turned into fabric or they will mix it with a resin to mold into a product. After they are spooled, they will be wound into a web and placed on a sheet of paper. The web is then heated up so that it will absorb the resin and is then rolled into a thin layer of carbon fiber. It is then cooled into a gel form. After this process is complete, they will take several samples and test them to ensure that it will withstand the amount of pressure needed for the application being used. Now that we've looked over how it's made, we're going to look over some of the mechanical properties and atomic structure of carbon fiber. To understand how carbon fiber is going to react to different stresses and temperatures, we first need to understand the mechanical properties. An important property of a material is the crystal structure of all the elements that make up the material. Carbon fiber has a very complex crystal structure called hexagonal close packed, also known as HCP. The fibers in the structure are anywhere from 5 to 10 micrometers in diameter and is mostly compiled of carbon atoms. It also consists of a type of polymer that is chosen based on the application of the specific strand of carbon fiber. So as we can see here, we're looking at the Young's modulus of carbon fiber. This is going to tell us how strong our material is overall. We're looking at 228 gigapascals, which is a very high modulus for any material. The tensile strength is 500 KSI, which means it's going to take 500,000 pounds per square inch to break carbon fiber. As we can see, it takes roughly 10 to 15 gigapascals to shear carbon fiber. Here we can see one of many chemical formulas. This is the most common chemical formula that we're going to see in carbon fiber. As well as carbon fiber is not a very dense material. This makes it very useful in applications because of its lightweight ability, but also still having high strength ability. Next, we're going to focus on the bonding material that we can see. Carbon fiber is known as a secondary bonding. This is caused because we have two different types of composites that are pre-cured and chemically attached. Our two different types of composites are polymer chosen based off the application, as well as carbon fiber is considered to be a composite. Next, we're going to look at some fatigues and failure. All materials are going to experience this. Carbon fiber has very few types of failure. The main type of failure carbon fiber experiences is going to be shear failure. This is caused by multiple cracks in the material that causes the material's internal integrity to be compromised. Next, we're going to look at impact loading, also known as fatigue. Carbon fiber is mostly made up of composites, therefore when under extreme loads and extreme impacts, it has a higher chance of failing. When carbon fiber is in degradation, its structural integrity starts to decline. The material is reaching its maximum allowable stress and will slowly start to become weaker, therefore it loses its tensile strength. As we can see, carbon fiber, even though it being a composite, does have corrosion, which most people would not assume that. Carbon fiber can experience a type of corrosion called galvanic corrosion. This occurs when carbon fiber comes into contact with certain metals, for example, aluminum alloys and titanium alloys. The way to avoid carbon fiber from corroding is to coat it in oxidation coatings, such as plasma electrolytic oxidation and other forms of coatings that keep the two materials from interacting with each other. Next, we're going to look at some of the economic impacts that carbon fiber has. It is important to understand the economic and environmental impacts of a material to see whether or not it has the ability to replace the material that you're looking at replacing. There are two main grades of carbon fiber. The first is aerospace grade. It costs anywhere from $85,000 to $200,000 per metric ton to produce. The second is an industrial grade, costing from $25,000 to $95,000 per metric ton. The reason carbon fiber is costly is mainly due to the equipment used to manufacture as well as the heat. It takes anywhere from 12 to 18 months to build a new carbon fiber plant. These plants cost millions of dollars. This is due to the high heat ovens that are required to melt down the fibers. Next, we're going to look at the pollution that carbon fiber has. Understanding the impact a material has on the environment is important so we can understand if this material is efficient to manufacture so that it can be more efficient than the materials we are replacing it with. Carbon fiber produces roughly 20 tons of CO2 released into the atmosphere per 1 ton that is produced. This is metric tons. Whereas there's roughly 2 metric tons of CO2 released into the atmosphere per 1 ton of steel. Although carbon fiber releases more emissions than steel, the benefits that come from it can help outweigh the drawbacks. Carbon fiber is roughly 5 times stronger than steel and only half the weight. This can help make the applications of carbon fiber more efficient, therefore helping reduce the overall carbon footprint of the material. Although every material has a pollution, it is important to look at the recyclability of the material. The most current way we can recycle carbon fiber is a process called pyrolysis. This process is going to use high heat to burn off the resin that we used in the manufacturing process to break down the carbon fibers, therefore they can be reused in the same manufacturing process to create another form of carbon fiber. Another process is also called solvolysis. This is used as a solvent to dissolve the resin off the carbon fiber. They take these fibers and turn them into a denser material to be used for different application. Once the fibers are densified, the carbon can now be used as a filament in 3D printing and injection molding. Although there is a way to recycle carbon fiber, roughly 30% of the material that is recycled goes to waste during these processes. Finally, we're going to look at the applications. Carbon fiber is used in many different fields because of its strength and weight. One important field that carbon fiber is used is the aerospace industry. It is used on planes to cut down on weight while still maintaining the strength requirement needed to fly in the air. Carbon fiber is also used in wind turbines. You can see that in the top right corner. This allows the blades to be stiff and withstand the force of the wind against the blade, while also still being lightweight enough, which allows us to get a more efficient and effective source of energy. Carbon fiber is also used in the automotive industry, more specifically in the racing industry and supercars. This allows them to still have that strength ability to withstand an impact from another car or any other crash impact, while still having the ability to have a higher speed with less horsepower. As we can see, carbon fiber is also used in the sports industry. It is used in any sports that involve handling a pole or a stick. This allows players to be more versatile while playing due to the weight reduction. As we can see here in a hockey stick, they're using that end and replacing the polymer with carbon fiber because of the lightweight and they're hollow. Carbon fiber is also used in the marine industry as well. It has roughly 2 times the strength to weight ratio than the most common material that is used to make boats. This is going to allow boats to be stronger and lighter, therefore making them easier to haul and faster on the water, as well as saving time transporting materials. That's all I have about carbon fiber. I hope you enjoyed the presentation.